Welcome to the informational series, Air Quality Regulations for Stationary Engines. For ease of navigation and quick reference, we've divided this series into 5 parts. This introductory module gives a general overview of the air quality regulations for stationary engines, to whom they apply, and some general helpful definitions. The additional modules of this series will walk you through each regulation and the requirements specific to the type of engine that you own. Modules 2, existing emergency engines, and 3, existing non-emergency engines, cover the requirements of the RICE rule. Module 4, new compression ignition or diesel engines, covers the requirements of the compression ignition NSPS rule. And finally, Module 5, new spark ignition engines, covers the requirements of the spark ignition NSPS rule. Melanie, why does EPA regulate stationary engines in the first place?
Well, stationary engines are common combustion sources that can have a significant impact on the environment and public health. Pollutants emitted from stationary engines are known or suspected of causing cancer and other serious health effects.
What other health effects?
They can range from aggravation of respiratory and cardiovascular disease, changes in lung function and increased respiratory symptoms, premature deaths in people with heart and lung disease, and complications with the immune and reproductive systems. Also, emissions of nitrogen oxides and volatile organic compounds can react in the presence of sunlight to form ozone, which can also cause a range of respiratory issues, including asthma among children and seniors.
Due to the nature of these health effects, it's important to reduce these harmful pollutants as much as possible. How has EPA addressed these issues?
EPA has developed 3 air quality regulations for stationary reciprocating internal combustion engines, or RICE. Collectively, these regulations are known as the RICE rules.
Can you elaborate on the 3 regulations?
Yes, the first is the National Emission Standards for Hazardous Air Pollutants for Stationary Reciprocating Internal Combustion Engines, known as the RICE NESHAP. And then the other 2 are our New Source Performance Standards. We have one for compression ignition engines, and then the other is for spark ignition engines.
Excellent. And so here we have an engine, a stationary engine, and this is used for what kind of different applications?
So yeah, this is a type of a stationary engine, and they're used in applications such as generating power and powering pumps and compressors, and then also pumping water in the case of fire or flood.
And then the EPA air quality standards really only apply to stationary engines, not the mobile, correct?
That's correct. These regulations don't apply to mobile engines, so anything that's self-propelled, such as a tractor, or anything that's on a piece of equipment that is intended to be propelled while performing its function, like a lawnmower, would not be covered by the regulations. And then also anything that's portable or transportable, meaning it's on a trailer or on a skid, would not be covered as long as it does not remain in the same location for more than 12 months or for the full annual operating period of a seasonal source.
This engine actually has wheels, so does that make it mobile?
In this case, because this engine remains at this location for more than 12 consecutive months, even though it is on a trailer and it has wheels, it's considered to be a stationary engine.
Okay, so how can owners determine what requirements fit for them?
So they would need to know whether their engine is a compression ignition engine or a spark ignition engine, what's the size of the engine, what's the age on the engine, and then also for purposes of the RICE NESHAP, they need to know whether or not their facility is what we call a major source of hazardous air pollutants or an area source of hazardous air pollutants.
Okay, what's area source?
So an area source is one that emits less than 10 tons per year of a single hazardous air pollutant, or less than 25 tons or more per year of combined hazardous air pollutants. And our information is that most agricultural facilities would be considered area sources. And we'll talk a little bit more about that in some of the other modules.
Let's start off with engine types. There are 2 main engines, compression ignition and spark ignition, like this one, correct?
Yes, that's correct. Compression ignition engines are generally those that use diesel fuel, where spark ignition engines, such as this one we have here, generally use gaseous fuels such as natural gas, propane, or landfill digester gas, and then also gasoline. That category of engines can also be further divided into lean burn or rich burn.
What's the difference between a rich burn and lean burn spark ignition engine?
A rich burn engine is any four-stroke spark-ignited engine where the manufacturer's recommended operating air-to-fuel ratio divided by the stoichiometric air-to-fuel ratio at full load conditions is less than or equal to 1.1. If you have an existing engine where there are no manufacturer's recommendations regarding the air-to-fuel ratio, it's considered a rich burn engine if the excess oxygen content of the exhaust at full load conditions is less than or equal to 2%. A lean burn engine is any engine that does not meet the definition of a rich burn engine. If you have an engine that was originally manufactured as a rich burn engine, but it was modified prior to June 12th of 2006 with passive emission control technology for NOx, such as a pre-combustion chamber, then it would be considered a lean burn engine under the regulations. If you're not familiar with how to determine whether or not your engine is a rich burn engine or a lean burn engine, your engine manufacturer or engine dealer should be able to provide you with that information.
Okay, thanks. The rule requirements also vary depending upon whether an engine is emergency or non-emergency. So when is an engine considered an emergency engine?
So emergency engines such as this engine that we have here provide electric power or mechanical work during emergency situations. So examples of that would be an engine that's used to produce power when power from the normal power source, usually your utility, is interrupted, which is what this engine here is used for. Other examples would be engines that are used to produce power in the case of fire or flood. The non-emergency engines are those that do not meet the definition of an emergency engine.
And we'll learn more about that in the other video modules?
Yes, we'll learn more about that in greater detail in those modules.
And finally, you mentioned that the rule requirements vary depending upon the age of an engine, whether the owner purchased a new engine or they're operating an existing engine. So can the owner determine if the engine is considered an existing engine based on the construction date?
Yes, they can. For purposes of the Rice NESHAP, the construction date is defined as the date that the owner-operator enters into a contractual obligation for the on-site installation of the engine. Keep in mind, this date does not change if an engine is moved to a new location. The engine is considered an existing engine if the construction date is before June 12th of 2006.
And we'll cover more of the requirements for existing engines in modules 2 and 3.
Yes, that's correct.
And what about new compression ignition engines?
So a new compression ignition engine would be one that's ordered after July 11th of 2005 and manufactured after April 1st of 2006, or if it's a fire pump engine, manufactured after July 1st of 2006. Also, older engines that are modified or reconstructed after July 11th of 2005 are also subject to the standards for new engines.
And we'll cover those in modules 4 and 5.
Yes, that's correct.
Okay. What about the spark ignition engines?
A new spark ignition engine is one that was ordered after June 12th of 2006 and manufactured after July 1st of 2007. July 1st, 2007, if the engine is greater than or equal to 500 horsepower, with the exception of lean burn engines that are 500 to 1350 horsepower. For those engines, it's January 1st of 2008. For engines less than 500 horsepower, they're new if they were manufactured after July 1st of 2008. And for emergency engines above 25 horsepower, they're new if they were manufactured after January 1st of 2009.
So Melanie, what does all this mean for farmers?
If they have determined that they have a stationary engine, then they need to comply with EPA's air quality regulations. Since the compliance deadlines have already passed, it's important that they contact their EPA regional office as soon as possible if they have not already complied with the regulations.
EPA's Agriculture and Air Quality website lists all ag-related air rules. Please feel free to visit this website and familiarize yourself with valuable information relating to the RICE rules, as well as other reference guides developed by EPA and the USDA. The overview of the RICE NESHAP requirements for stationary agriculture engines can be found at the bottom of the page under the EPA National Air Toxic Standards heading. This link also provides a list of regional contacts. Melanie, thanks for explaining why EPA regulates stationary engines and going over the general compliance requirements. The following modules will go over the specific requirements for the different types of engines.